Okay, so now that we are done learning all the things that we can say about functions, we're going to learn the 12 basic functions. These would be the things that were on my board, if you remember, as we did them in Algebra 2. Now, we did not do in your class probably 4 of them because we did not do the sine and cosine curve that I usually do. But you're going to be given these functions, and then you're going to be able to do the things that we just got done talking about: domain, range, increasing, decreasing. Are they continuous? Are they bounded? Etc. So as we continue to study math, just sort of what you can say, you will find that the 12 basic functions presented here come up again and again. By knowing their basic properties, you'll be able to recognize them when you see them. So we know the vocab for talking about functions and the properties. We're going to introduce the 12 basic functions that we're going to study in depth this year. And we do, sine and cosine are the ones we do the second semester. The other 10, we do 8 of the 10 this first semester. So you will see this. What I've given you attached on the playlist is, it's sort of a little picture with these pictures, and then it asks you like domain, range, etc. What I would try to do is, just to get better at it, try to analyze some of these functions. So first of all, if I just go through them, you have to either know the name or the equation. Most people know the equation. I know y for some of them. You could know the equation for some, the name for the others. The identity function is y equals x. Why is it called the identity function? They're the same identity. Squaring, y equals x squared. Cubing, y equals x cubed. The reciprocal is your rational function, 1 over x, where you have the 2 branches. We did do that in honors. We did those graphs, but that was online in like April. Square root function, we did. Exponential function, now they have e to the x. I talked about the number e, but you'll see in my packet, I did y equals 2 to the x, and I also did y equals a half to the x. 2 to the x is exponential growth. A half to the x is exponential decay. Natural log, which it's y equals ln of x, but remember, ln is just log base e. I could have put y equals the log of x, which is log base 10. Doesn't matter. Sine and cosine, which we did not do, but you will see sine and cosine are a little bit different in the fact that the main thing, one is even and one is odd. So their symmetry is different because of where they sort of start. Absolute value, we did. Greatest integer, that is something we really don't talk about in math. I talk about it, I introduce it. And then we have this logistic function. And a logistic function looks like a cube root, but it doesn't go through 0, 0. So that's sort of different in how it looks. So, what would I do if I'm looking at these? So what you should be able to do on that packet, you think the 10 things: domain, range, increasing, decreasing, continuous, boundedness, extrema. I'm just going to keep writing. Asymptotes, end behavior, symmetry. And what ends up happening is you have to be able to know what these things look like. If I say, well, what's that domain? You can look at the function down here and say, well, could I ever get 0 in the denominator? You can't, because you're always adding 1, and e to a power is never going to be -1. So you could also look at the graph. Domain is all x's. Range, well, where are your y's? Your y's are between 0 and 1. Now people will say, why didn't you use a bracket? It's not hitting 1, it's got asymptotes. Increasing or decreasing, I look left to right. Left to right, that thing is increasing always, never decreases. Is it continuous? Does it have any breaks? No, so it is continuous. Bounded. So this is an example of a graph that is bounded below and above. So this thing is bounded. Otherwise, you would say like bounded above, bounded below, or you say not bounded. Does it have extrema? No maxes or mins. It never has a high point, a peak, or a valley. Symmetry. Some people would say, yeah, it flips over this point. Well, that's not the origin. It's either even, odd, or neither. Y-axis symmetry, origin symmetry, or neither. So, neither. Asymptotes. Yes, it gets closer and closer as you go to infinity. It's getting closer and closer to 1. Negative infinity, it's getting closer and closer to 0. It does not have any vertical asymptotes, so those are y's. End behavior, you're always going to write as x goes to infinity. As you look to the right, where's your graph going? Well, this one is getting closer and closer to 1. As I look to the left, where's my graph going? It's getting closer and closer to 0. So that's what I mean by analyzing. And I would try some, because really what you're going to see like towards the end of the week is what ends up happening if you know these things. If I say, well, which ones have domain that are negative infinity to infinity? In your mind, you have to have looked over these. If you're just going to say, oh, I'm going to look at one, I mean, you have to think, well, give me a couple that have domain negative infinity to infinity, which would mean there's no breaks and all x's work. A line, absolute value, parabola, which is x squared, x cubed, what I just did, logistic, etc. Okay, so you have to look them over to be able to answer the questions. Where this takes you is really you're going to be asked to analyze a graph. And so I'm going to give you some form of one of those things or a combination, and you're going to have to tell me everything about that graph. So this just gives you a way to sort of practice that. Okay, so hopefully that helps. Fill out that form for every one of those. I would say probably not everyone, but I would look at them. At least try a couple. And I'll talk to you the next day.